I want to do one last example in this section just to put it all together. So here we want to try to find the volume of the solid who is bounded above or lies below the surface f of xy equals square root of the quantity x minus y times x plus 4y, and above the region R that has the vertices 0, 0, 1, 1, 5, 0, and 4, negative 1. Okay, so you can see here I've already sketched my region R, and we could use tools from previous sections to just find this, this volume, but you can see it would be kind of messy, right? So if I take vertically simple region, y is going to range from this line to this line as I move up to this point. But then as I move past this point, y goes from the bottom line to this top line up until that point, at which point y ranges from this line to that line. So I would in fact have to create 3 double integrals in order to integrate to find the volume here. And so our change of variables is going to make this a simpler integral to handle. All right, so to do the change of variables, the first thing I need to do is figure out what my boundaries are. So I'm going to take my lines here and find their equations. Now you can just do this like you would normally if you know 2 points on a line. So let's work through this one using point slope. I'm going to have y minus 0 equals change in y over change in x. So 1 minus 0 over 1 minus 5 times x minus 5. I've used 5, 0 as my point, which is y equals negative 1/4 times the quantity x minus 5. Now if I multiply through by a 4, I get 4y equals, let's do negative 4 actually. Negative 4y equals x minus 5, and then let's rearrange. So this says x plus 4y equals 5. All right, and we like to arrange it this way because that'll help us figure out what we want to be u and v. Okay, so I'm going to just tell you what I got for the other lines. This line, once I rearrange, looks like x minus y equals 5. This bottom line looks like x plus 4y equals 0. And this line on the left looks like y equals x, which becomes x minus y equals 0. Okay, so this is what's going to help us figure out what our transformation is. I can see here I've got x plus 4y and x plus 4y there, and an x minus y and an x minus y. So I want one of those to be u and one of those to be v. So I'm going to let u be x minus y and v be x plus 4y. Now what I really want is the transformation that takes uv to xy, right? So I need to solve for x and y in terms of u and v using this equation. So what I'm going to do here is I'm going to subtract so that the x's cancel. So I get u minus v equals negative 5y, and I'm solving for y, so divide by negative 5. I get negative 1/5 u minus v equals y. And now I can plug into the top equation here. So u equals x minus y, so plus 1/5 times the quantity u minus v. And I want to solve for x, so I'm going to subtract over. So I get u minus 1/5 u is 4/5 u, and then I'm going to add 1/5 v to both sides, so plus 1/5 v. Okay, so I want my t from S to R given by t of uv equals x, so 4/5 u plus 1/5 v y, so negative 1/5 quantity u minus v, and that's my x comma y. Okay, so the next thing I want to do is find the Jacobian here. So the Jacobian is the determinant of the 2 by 2 matrix, where I'm first going to take the partial of x here with respect to u. So I get 4/5 in the top left corner. Then partial of x with respect to v, I get 1/5. Partial of x with respect, partial of y with respect to u gives me -1/5 in the bottom left. And then in the bottom right, I want the partial of y with respect to v. I'm going to get a +1/5. And I want the determinant of that matrix. That gives me 4/25 minus -1/25, which is 5/25, or 1/5. All right, so let's try putting it all together. So I want the double integral over r of my function, which was square root of x minus y times x plus 4y dA, is going to become the integral. Whoops, we forgot to say what our boundaries were, so let's squeeze that in. Let's see. I'm trying to look for space. Let's just cut this for a second and we'll scooch it down. So boundary in the xy plane versus boundary in the UV plane. All right, so here they were. I had x minus y equals 0, x minus y equals 5, x plus 4y equals 0, x plus 4y equals 5. So x minus y, remember we let u be x minus y, so this is u equals 0, u equals 5, v equals 0, v equals 5. All right, so integral from 0 to 5 of the integral from 0 to 5, square root of, here I have u times v, right? uv times the absolute value of the Jacobian, 1/5, du dv. All right, and you can see that's a lot simpler to integrate, right? All right, let's go ahead and just do this integral. So I have the integral from 0 to 5 of the, let's go ahead and integrate. I have 1/5 times, I have a u to the 1/2, so I'm going to add 1, so u to the 3/2, and then divide by 3/2. Evaluated from 0 to 5. And I've still got a v to the 1/2 here and a dv. That's going to be the integral from 0 to 5 of, let's see, I'm going to have a 5 to the 3/2 there, and so a 5 is going to cancel in my numerator and denominator, so I'm left with 2 root 5 over 3 times v to the 1/2 dv. Let's see if we can squeeze it in here. I have 2 root 5, whoops, and I lost my one, oh no I didn't. 2 root 5 over 3 times v to the 3/2 times 2/3, evaluated from 0 to 5. And let me just tell you what we get, 100 ninths. So 100 over 9. All right, and so there's an example where we've put all of this together. As always, let me know if you have any questions.